Hello class, welcome to 3.4. Solve geometric applications related to triangles, rectangles, and the Pythagorean Theorem. We look at three objectives. Solving applications using triangle properties using the Pythagorean Theorem, and solving applications using rectangle properties. So by properties, it's good to have a collection of what they mean. So let's start with the triangle ones. The triangle properties, as the name says, triangle, which means it has three angles. The three angles add up to 180 degrees. Any triangle, it will always add up to 180 degrees. That's what the first property says. The second property is about the perimeter. We're always concerned about the perimeter and the area for triangles and rectangles in this section. So the perimeter is always the sum of the sides. Okay, peri means outside, meter means measure, the measure of the outside. So the measure of all the sides, meaning the sum of all the sides, would give you the perimeter. A triangle has three sides, so you have A plus B plus C, the three sides. When it comes to area, area involves the height. So as you can see, the height here is a perpendicular line that hits the base of the triangle. And so if you have information on the height, you can find the area of a triangle. You have A equals half times base times height, half BH. And you have the three properties given to you in this box. First problem, the perimeter of a triangular pool is 36 yards. The lengths of two sides are 10 yards and 15 yards. How long is the third side? Okay, understand the problem, and let's draw a diagram. It's good to draw a triangle just so we can visualize it. It doesn't have to look perfect like this because I just used a template, but you could just draw any triangle and fill the details. Okay, the perimeter is 36 yards. The perimeter, peri means outside. So the sum of all the sides is 36 yards. So I can't put that on the triangle yet. But we are told that the lengths of two sides are 10 yards and 15 yards. Okay. Let's say 10 yards, one of the sides. The other side is 15 yards. And we are asked to find the third side. Okay. But we are given perimeter. So let's write that. Perimeter is A plus B plus C. That's the property. Any one could be A, the other could be B, and the other could be C. So we have 10 as one of the side measure. 15 as the other. We don't know the other ones. I'm going to call it C itself. But we do know what perimeter is. Perimeter is 36. So I fill the left side with 36. All right. So we have 36 equals 10 plus 15, 25, plus C. Get C by itself. Very, very straightforward problem. This implies C equals 11. Again, it's a word problem, so go back and say 11 yards. Okay, so that's our first problem. Our next problem is a triangular flag has base 1 foot and height 1.5 foot. What is its area? So again, recognize the shape. The shape is a triangle. Okay, and the height is always dropped perpendicular. So I have that. Okay, now the base is given to be, the base is always where the triangle is flat, right? You can imagine like that, the base. So 1 foot. And the height, so this is your B, base, right? And the height H is 1.5, okay? 1.5 feet. Now the area of a triangle, that's shortcut for a triangle, is half times base times height. Okay, now go ahead and plug them in. Half times base is 1 times height is 1.5. You know, these are all being multiplied, so you can multiply them across. Again, if you need a little help, you can always drop a 1 underneath it, so you know that you have to multiply them across. All the numerators together gives you 1.5. All the denominators when multiplied gives you a 2. So you do 1.5 over 2 in your calculator, it comes out to be 0.75. Okay. Now this is area, right? Yeah. So base was a foot and height was a foot. So you basically had foot times foot, okay, or rather feet. So I will just say feet, even though it is like foot. Okay, just because you're familiar with this. Feet times feet is feet squared or square feet, right? So area is 0.75 square feet. Okay, in this case, it was square foot. Okay, so that is your area. Next, we move to Pythagorean theorem. We really love this theorem because this theorem is really very simple, and it's somewhat intuitive too in a way. The Pythagorean theorem works only in right triangles. This theorem, right triangle means the triangle has, and one of the angles of the triangle is 90 degrees. Okay, so I'll just write somewhere here. Right triangle means one angle is 90 degrees. Okay. So the 90 degrees usually drawn as a box, because only for a 90-degree angle can you draw a box, right? Otherwise, it's going to look more like an arc. So the box usually represents 90 degrees, so they don't tell you explicitly it's right triangle. The diagram, the symbols speak for itself. Here we have, again, A, B, C as the sides, but we have a special understanding with the sides this time. Okay? The C is always your hypotenuse. Well, it's a strange word, but remember this was due to Egyptian influence and all that. So we have C as the hypotenuse, but to put it in English, hypotenuse is always the longest side. Okay. C is always your longest side. How do I know which is the longest side? Well, remember the property of a triangle says the three angles must add up to 90 degrees, right? I'm sorry, 180 degrees. All three angles of a triangle will add up to 180 degrees. If one of the angles is already 90 degrees, right, the remaining 90 degrees must be shared between the other two angles, which means they will definitely be less than 90, isn't it? So 90 is the largest angle among the three angles in a right triangle. And the side opposite the largest angle is always the longest side. That's a property in geometry. The side opposite the largest angle is the longest side. Likewise, the side opposite the smallest angle is the shortest side. And that's a relation. And therefore, you will always know what the longest side is as long as you have the side opposite the 90-degree angle. Okay, and this is the property. It says a squared plus b squared equals c squared, right? The other two sides are called the legs. It doesn't matter which one is a or which one is b. But if you added the squares of the other two legs of the triangle, it will be equal to the square of the longest side, the hypotenuse. Let's look at this example here. So they've drawn a box here for the angle, which means we know it is going to measure 90 degrees. So this is a right triangle. A check mark for that, because without it, you can't really apply the Pythagorean theorem. So the side opposite the 90 degree will always be your C. So C is unknown at this point. They're asking us to find the length of the hypotenuse. So now we are ready to use the formula. So C squared equals A squared plus B squared. Any one could be A. So your A could be 3 squared. The B could be 4 squared. That's going to be 9 plus 16, C squared. C squared equals 25, right? Now, 25 could be, the square root of 25. You've learned about square roots in your Math 80. The square root of 25 could be plus or minus. But here we're talking about the length of a side. So this implies C is positive square root of 25, which is 5. They didn't tell us if it was feet or inches, and so we really don't know what that is. So we'll simply come back and say length of the hypotenuse equals 5. Okay, perhaps box the answer there. So we know that was what we're trying to find. And that's the end of it. Let's look at the other problem. Here again, we have the box indicating 90 degrees. And the side opposite 90 degrees is the longest side. It's always your C, your hypotenuse. Seems like C is given to us, right? And we're asked to find one of the legs. So because it's a right triangle, we are free to use the Pythagorean theorem. So C squared equals A squared plus B squared. Just that C is known, and maybe we could call the 5 as the A. So I'm going to plug in C as 13. That's getting squared. A is 5. That's getting squared. Plus B squared. Okay. So 13 squared is 169. And 5 squared is 25 plus B squared. Okay, I don't have room beneath it, so I'm going to just use this space here. Okay. Okay, now we need to get B by itself. So I'll just write it out here. 169 equals 25 plus B squared. I need B squared by itself. So I subtract 25 on both sides. 169 minus 25 is 144 equals B squared. Use your calculator. The positive square root of 144 is 12. Again, they didn't give us any information there. So we'll just say the length of the leg is 12. Okay. So why do we need this Pythagorean theorem? Do we even use it in real life? Here is a problem that attests to it. Kelvin is building a gazebo and wants to brace each corner by placing a 10-inch piece of wood diagonally as shown above, right? It's shown above there. So that's the brace that he's using. If he fastens the wood so that the ends of the brace are the same distance from the corner, what is the length of the legs of the right triangle formed? Approximate to the nearest tenth of an inch. Okay. The details are kind of given to us, 10 inches and X. But let me just maybe outline it in red so you can actually see what we're talking about. I kind of had to thicken it so you can actually see it. So that's a triangle, right? And that's a right triangle because you have that 90-degree angle there forming. So if I were to kind of draw that out here, this would be 10, this is X. And we're told that it's the same distance from the corner, which means it's X here and it's X there. Now that wasn't explicitly given to us, but that information comes right from here. Okay. So that the ends of the brace are the same distance from the corner. That information tells me that both the legs of the triangle are the same measure. Okay. Again, this is a 7-step process. Okay, read the problem, identify what we're looking for. That's step 2, right? What we're trying to look is to find the length of the legs. Okay, length of the legs. That's what we're trying to find. Okay, and we need to use a variable for it. In fact, they gave us X in the diagram, so we're going to keep the X. So I'll just say X is the length of the leg. There are 2 legs. Each leg measures X, so it's enough that you find one of them. That will give you information on the other. Once we have that, we need to use the Pythagorean theorem, which is, we're permitted to use the Pythagorean theorem because it forms a 90-degree angle, because it's a right triangle that's formed. C squared equals A squared plus B squared. C squared is the longest side, which is 10. That has to be squared. A, we don't know what A is. A is one of the legs, but we do know that A is now taking the variable X. Let's have X squared. But we also know that B measures the same as A, so that's also going to be X. Right there you have 100 equals X squared plus X squared. X squared and X squared are like terms, so you can add like terms. So that gives us 100 equals 2X squared. Then I take it up here. 100 equals 2x squared again, and divide by 2 on both sides. Okay. That gives us 50 equals x squared. Okay. Now they're asking us, if you go back to the problem, it says approximate to the nearest tenth. That's a crucial information. If we don't do that correctly, then our answer will be marked wrong. So x equals square root of 50. We know that, positive square root, because these are all lengths. But so anyway, to round it to the nearest tenth, you need to use the calculator. So go ahead and say find square root of 50. That comes out to be 7.07106 and so on, right? But they want us to approximate it to the nearest tenth. Nearest tenth is 1 decimal place. So this is the decimal place we need to round. So look at the number to the right. That number is above 5, which means you need to add a 1 to the 0. So your approximate answer would be 7.1. They've given us inches as the measure, right? So we come back and add it as inches. So of course we have to conclude the answer. The length of each leg is 7.1 inches. Okay. That helps us to conclude that answer. And for our last problem, John puts the base of a 13-foot ladder 5 feet from the wall of his house as shown below. Okay, you have it right there, 5 feet. That's the base. How far up the wall does the ladder reach? It's a 13-foot ladder, so you know the length of the ladder. You know how far away it was placed from the house. You know, it was away from the house at the base of 5 feet. So we need to know how far up the wall the ladder can reach. Okay, let's zoom that problem out by drawing that triangle. So I'm just going to, it's a colorful picture, so I don't know if you can even see what I'm drawing. So I'm just going to draw that out here. So we're told this is 5 feet. The ladder is 13 feet. We need to find this one. You know, the wall makes a 90-degree angle with the ground. Therefore, we know it's a right triangle. So we're free to use the Pythagorean theorem. So just like that, you could use the Pythagorean theorem, which is c squared equals a squared plus b squared. Let's quickly identify which one is c. C is the side, the longest side, so it's always opposite the 90 degrees. So 13 is your c, which means 5 is your leg. So that's going to be 13 squared equals, we'll just call a as 5 plus b squared. So it's very similar to the other one. 169 equals 25 plus b squared. Subtract 25 on both sides, we get 144 equals b squared. B is square root of 144, which is 12. Being a word problem, we come back and say how far up the wall does the ladder reach? The ladder reaches 12 feet up the wall. Okay, box your answer. Hope that was helpful. I will see you in the next video.